I said, these are 3 things you need to know how to do. This was yesterday, so that's Tuesday. This we'll talk about a little bit today. This you did on Monday. Mr. P, how can I go review? You can look at your worksheets, or you can also go into the Schoology folders for Monday and Tuesday. You can take a look. But let's do a little bit of this work today. So we're looking at this worksheet right here. This is below the video if you're on Schoology. All right, so practice interpreting the data. So here's a question I could ask you on your quiz tomorrow. Identify the graph that matches each of the following scenarios. Like, okay, so I got 1, 2, 3 graphs. They have distance from home and time. All right, cool. So I just left home and I realized I forgot my book, so I went back. So this person should go away from home and then come back. Things went fine until I had a flat tire. I stopped to fix it, and then I continued on to school. And then thirdly, I started walking slowly but sped up when I realized I was going to be late. Okay, so let's take a look at this graph. This person was getting a little bit away from home, and then they started getting away from home more and more and more. So that tells you they started going faster, okay? Which scenario does that sound like to you, Layla? They started walking a little bit, they were like kind of going slow, but then they started going a lot faster. Scenario 1, 2, or 3? I'm sorry, A, B, or C. My apologies. Which one does that look like? So we're trying to figure out, this graph goes with one of these 3, A, B, or C, and I'm trying to figure out which one that goes with. So we kind of were looking at this graph, like this person was kind of getting away from home, and then they started getting away from home really quickly. Yeah, I love it, right? They're like, I was kind of walking slowly, but then I had to speed up. So you would kind of put, this is graph number 1. Looks good. Enrique, this person got away from home, and then like they weren't going anywhere, and then they got further away from home. Which scenario does that seem to line up with? Yeah, love it. Boom, boom. So that means that 3 should be the first one. Let's just make sure that makes sense. This graph says they went away from home, but then they went back to home. They went back to a distance of 0. So they must have gone backwards, and then they left again. This person, I left home, and then I realized I forgot my book, so I had to go back. Oh, okay, yeah, that does seem to make sense. So I'm going to give you guys 5 minutes to work on this, and then we're going to move on to the next thing for today. In the meantime, I'm going to drop off these yellow sheets of paper. They're the answer key to this worksheet, so you can kind of check yourself as you go, okay? All righty, get her cooking. All righty, so like I said, tomorrow you need to be able to make a graph, which is what we practiced yesterday, but you also need to be able to read a graph, okay? So that is what we are going to be doing here today, or that's what we just practiced here today. So like this guy, the pie graph at the right represents the typical day of a teenager. Remember, a day, how many hours are in a day? 24 hours, so that's just one thing you need to know. What percent of the day is spent watching TV? So if you want to know what percent of the day is watching TV, you got to add up all these percents here, find out what's left over. So 50, 75. Yeah, so these all add up to 87%. So how much is left over of 87% spent not watching TV? 13%. There you go. Yep. So a lot of people are on the right track there. So make sure you can read graphs tomorrow as well as make them. Okay? So that's that. Now let's go ahead and talk about how we do science. Okay? So these are our guided notes. How do we do science? So here's a little scientific method graphic right here, showing it's a little bit cyclical. But here's what we're going to be doing, okay? So today, you guys are going to start writing a procedure for a lab, like you're going to write the instructions. Tomorrow, you guys are going to take your graphing quiz. Friday, you guys are going to do the lab that you write the procedure for today. So today, you won't be doing a lab, okay? But you're going to write how to do your lab for Friday. So when Michael walks in on Friday, the only instructions he's going to have are the ones that he wrote today. Does that kind of make sense? So on Friday, you can't be like, wow, this doesn't even make any sense. Who wrote this? Like, oh, wait, Wednesday, Michael wrote this. So that's on him. So that's the guy you need to rely on Friday. So you want to make sure we're ready to play today. We're going to take a few notes, and I'm going to show you guys how to write a procedure. So it all starts with a research question. We don't do any science unless we have a question about something. Okay? We won't write science until we have a question about something. So, we're going to start with our hypothesis. Our hypothesis should be based on prior knowledge or some sort of observation. Prior knowledge or some sort of observation. Maybe just missed a couple of you guys. Ian, you can just place that right there on the table if you want to go the other way. Here you go. And your hypothesis should be a statement. Okay? It should be some sort of statement. So you guys have often written hypotheses as questions, but that's not how we're going to do it in this class. It should be a statement. So you're not saying, I wonder if, or if then. You're just saying, this is what's going to happen. Now, later you'll talk about, that's actually not what happened. Or be like, yeah, that is what happened. So you're just going to write a statement about what you think is going to happen, and you're just going to write it as a statement, not like a question or anything like that. With your experimental design, there's some things you want to keep in mind. So your variables, those are the parts of the experiment that you want to control. Okay, so there's a lot of things you want to control and keep the same every time. Today, or in this lab, you guys are going to be boiling water. So for example, one thing you want to control is how much water you use. Mr. P, how much water should we use? Yes. I don't know. You guys get to pick. We just want to make sure it's the same every time. So maybe Aiden's group uses 200 milliliters of water, but Bo's group only uses 100 milliliters of water. You just need to make sure your group does the same thing every time. Okay, so that's one of the things you'd want to control. That's a variable you'd want to control. Now, whenever we do an experiment, we should do everything exactly the same, except what? There's one thing that we should do differently every time, and that's called the what? Independent variable, right? You want to change one thing on purpose because you want to see what it does. You want to test it. So only one variable should change during the course of an experiment. I'll just put like a little note. That's your independent variable. That's your one change. Is your independent variable. Okay? And you're changing that on purpose. So Abdullah, he's like, all right, I'm going to change this on purpose because I want to see what it does. I want to know what happens. All right, now you do need a control for anything. Okay, so we've sometimes called the control our normal. Sometimes we refer to that as the normal. Okay, but in terms of the blanks on your guided notes here, that's the sample that is the same as all the rest, except nothing changes about this group. And here's the really key word. It's what you use to compare. How do you know the water boiled faster? How do you know the water is hotter? Or how do you know this or that? Well, it's hotter than my control. It heated up faster than my control. You always have to be able to compare it back to your control. So control is necessary so you can make a comparison. All right. So your experimental design will need to include, now I wrote the word repeatable here. Again, people should be able to do your experiment with just your instructions. They should be able to do your experiment with just your instructions. So a procedure is a step-by-step description. When you guys write procedures here in a little bit, here's a tip for you. Use numbers. So when you're writing your procedure, okay, let's say I'm Jason M. and I'm writing my procedure, I'd be like, number 1, blah, 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 blah. Number 2, blah, 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 blah. Number 3. Like, I would just use numbers, okay? Materials, list all your supplies and your equipment. Luke better not be like, okay, now go ahead and get the beaker out. He should be like, get the 250 milliliter. Like, you need to make sure you tell me which size we're talking about, okay? Or maybe Nevaeh's like, measure with a graduated cylinder, be like, which one? 10 milliliter graduated cylinder or the 100? Does that kind of make sense? You want to always tell me what size you're talking about. Then you don't have to tell me what size Bunsen burner because there's only one Bunsen burner, right? But there are multiple beakers and that kind of thing. Now, when you're collecting your data, okay, that's something you should be doing throughout the experiment. That's the main thing you're doing, in fact, during the experiment, just collecting your data. So you want to use your senses to make observations. Whoopsie. You don't want to throw your smartboard eraser, though. Now, there are two things that your data should be. They should be numbers, so 33 degrees Celsius, 100 milliliters, something like that. Or they could be descriptions. So Azaria could say, the water began to boil. That would be a piece of data that was a description, not a number. Okay, he could say the water began to boil. Now, data should always be recorded in a table. You guys are going to get a handout from me in a minute here. This guy, in fact. And it has a little data table. So I'm holding up your worksheet. So your data should always be recorded in a table, okay? And I want to make this point. Don't forget your units. So when you're looking at your data table later, here's what it looks like, by the way. When you're looking at this data table later, always make sure you put units right here. Don't just say time. Tell me seconds, minutes, days, whatever. And your temperature will be in degrees Celsius for this particular one. So you want to make sure you write those once you get this handout. But we'll come back to that later. Now, last few things. Conclusion. Okay? You need to answer your research question. You need to say, we found out that blank. Your hypothesis, that was a statement earlier. You didn't ask it as a question. You just have it as a statement. You need to say whether you accept or reject that. So Jonas has to say, I accept my hypothesis earlier. Or, yeah, I reject my hypothesis. It wasn't right. Okay? But don't just say whether you accept or reject it. You got to tell me why. So Jonas would be like, we should not accept my hypothesis earlier because, and he's going to mention his data. Because at 2 minutes, 8 minutes, and 12 minutes, the temperature was blank, blank, and blank. Okay? Something like that. So he's going to use his data table to explain himself. So that's how we do science. That's what you guys are going to be doing here. I'm going to stop my recording for those of you guys at home. Just